Imagine an AI that can write code, drive a car, negotiate contracts, and manage your entire digital life. Sounds like the future, right? That future is happening right now in the form of autonomous agents. But here is the scary part. These systems are getting smarter faster than we can build safety checks for them. We are standing on the edge of a cliff where one wrong step could mean total system failure or even real-world harm. In this video, I am going to show you exactly how to build invisible shield walls around your autonomous agents before they ever see the light of day. You will learn 4 critical guardrails that turn dangerous experiments into trusted production tools, and why ignoring them now will cost you everything later. The first thing you need to understand is that an agent's brain is only as good as the garbage it eats. If you feed a self-driving car a map with missing streets, or give a coding bot a prompt riddled with malicious SQL commands, those systems will hallucinate their way into disaster zones without blinking. Input validation isn't just about checking for typos. It is about creating a strict perimeter that filters out anything that does not fit your specific operational reality. Think of it like a bouncer at an exclusive club who rejects anyone trying to sneak in with fake IDs or oversized bags before they even step through the door. In practice, this means building layers of scrutiny on every single input stream. Before your agent makes a decision, you must validate that data comes from trusted sources and matches expected schemas. For instance, if an agent is designed to manage inventory, it should be impossible for it to accept text descriptions of products as numeric IDs unless explicitly told so. This stops the kind of lateral thinking attacks where bad actors try to trick the system by injecting noise into the conversation. By enforcing rigid input rules early on, you create a digital moat that keeps unauthorized or malformed data from ever reaching the core logic. It is the difference between an agent following instructions and an agent rewriting them based on half-truths. Once your agents have clean inputs, they need to know where they are allowed to go. This is where action boundaries come in. An autonomous system should never be able to do something outside its designated scope of authority. Imagine a security guard who is told to patrol the lobby, but suddenly decides to enter the server room because he feels like it. That is exactly what happens when you lack hard action boundaries. You must define a strict list of tools and actions your agent can invoke, and nothing else. Beyond simple permissions, you need dynamic circuit breakers. These are intelligent systems that monitor the agent's behavior in real time and automatically halt operations if something goes wrong. If an agent starts making too many failed API calls or attempting to access sensitive files it shouldn't see, the circuit breaker should trip instantly, cutting off power to its reasoning engine immediately. This is crucial for high-stakes environments where a single misstep can lead to financial loss or data breaches. The beauty of this approach is that it allows the agent to learn and function normally under normal conditions while providing an automatic emergency stop when things go south. It turns potential disasters into manageable incidents. Even with perfect inputs and strict boundaries, how do you ensure your AI aligns with broader organizational values? This is where the trust layer enters the picture. Autonomous agents operate in a complex web of data and logic that can easily drift from company policy or ethical standards if left unchecked. You need a built-in mechanism that continuously evaluates every decision against your organization's specific rules, regardless of how smart the agent appears to be on paper. Think of this as an internal auditor that runs alongside the agent during its entire workflow. This system checks for toxicity, bias, and compliance violations before any action is executed or logged. For example, in a customer service scenario, if the agent starts adopting an aggressive tone, even though it was instructed to be empathetic, the trust layer flags this deviation immediately. It ensures that the agent's internal reasoning process does not conflict with external legal or ethical requirements. By integrating these checks directly into the platform, you create a safety net that protects your brand reputation and keeps you compliant with regulations without needing constant human supervision. The final piece of the puzzle is what happens after the agent acts, but before it reports back to you or its users. This is output filtering, which serves as a last line of defense, ensuring that everything communicated back to humans is safe, accurate, and appropriate. An agent might successfully execute a complex task internally, but if it then generates a report with hallucinated data or harmful language, the damage is already done before your eyes. Output filtering acts like a spell checker on steroids for your AI's conclusions. It scans every generated response, file output, or notification against your content policies and accuracy thresholds. If the agent suggests a financial strategy that violates current market conditions or produces code with known vulnerabilities, the filter blocks it from reaching the user. Furthermore, maintaining detailed logs of all filtered outputs allows you to review past interactions for patterns of failure or emerging risks. This closed loop of observation and correction ensures your system evolves safely over time, rather than accumulating hidden bugs or dangerous behaviors that could explode at any moment. Building safe autonomous AI is not about stopping progress. It is about accelerating it responsibly. By combining strict input validation, rigid action boundaries with circuit breakers, deep trust layer integration, and robust output filtering, you create a fortress around your intelligent systems. These guardrails do not hinder innovation. They enable it by giving developers the confidence to deploy powerful agents in real-world scenarios. Don't let safety become an afterthought, because once your agent goes live, there is no going back. Subscribe for more deep dives into the future of AI, drop a comment telling me which guardrail you implement first, and let's build the next generation of safe, reliable automation together.